Hi madam, we are from Group 4 and today we are going to present our project which is design and implement of a secure enterprise network infrastructure. So here are my team members, me, Eng Lingna, Lim Si Hong, Nurul Shafika and also Peggy Chua Peggy.
Next, for part A, for small office, home office, home network design with guest network. For SOHO part, IP address range. The first device is R1. They have two interfaces, G0/0, G0/1. The IP address is the same, 192.140.40.1. Subnet mask for G0/0 is 255.255.255.192. And for G0/1, the subnet mask is 255.255.255.240. Both of them have no default gateway. The next devices is PC0 and PC5. All have the same interface, F0, but have different IP address. So from PC0 starting with 199.40.40.2, and PC1 199.40.40.3, PC2 199.40.40.4, PC3 199.40.40.5, PC4 199.40.40.6, PC5 199.40.40.7. They all have the same subnet mask, 255.255.255.192, and also the same default gateway, 199.40.40.1. Next is the FTP server. They have the same interface as before, is F0, and the IP address is 199.40.40.60. They also have the same subnet mask as above, 255.255.255.192, and also the same default gateway, 199.40.40.1. Next is for the guest. We have three, which is guest 1, guest 2, and guest 3. All have the same interface, F0. For the IP address, we starting with guest 1, 199.40.41.2, guest 2, 199.40.41.3, guest 3, 199.40.41.4. They also have the same subnet mask and default gateway. For subnet mask is 255.255.255.240. Default gateway is 199.40.41.1. And last one is backup PC. The IP address is 199.40.40.50. Our network consists of two separate groups: staff network 199.40.40.0/26, contractor network 199.40.41.0/28. So a file server is deployed at IP address 199.40.40.60 to provide FTP services. Firstly, we will verify router interfaces. So we will open router R1 CLI and then put command show IP interface brief. This command display our router interfaces and their IP addresses. We can see that the staff gateway and contractor gateway are active and operational. Next, we will verify VLAN configuration. We will open switch S1 CLI. Command show VLAN brief. So this output confirms that VLAN 10 is active on switch S1 for staff users. And then we open switch S2. Command show VLAN brief. This output confirms that VLAN 20 is active on switch S2 for contractor users. After that, we will verify SEL configuration. We will open router R1. Command show access list. So this SEL is used to control contractor access. Contractors are blocked from accessing internal staff resources while still being allowed to use FTP services. Next, we will do staff connectivity test. We open staff PC. Command ping 199.40.40.60. This test confirms that staff users can successfully communicate with the file server. The successful reply indicates that connectivity is working correctly. Next, we will do contractor access test. We open contractor PC. Ping 199.40.40.2. This test attempts to reach a staff device. The request fails because the ACL blocks unauthorized access. This demonstrates that our security policy is functioning correctly. Next, we will do FTP access test. Still on the same contractor PC. Command FTP 199.40.40.60. Next, enter the username and password. Although contractors cannot access internal staff devices, they are allowed to access FTP services. The successful login confirms that the ACL permits FTP traffic while blocking other services. Next, we will do demonstration on port security. We open switch S1 CLI. Command show port security. So port security is enabled on access port. This feature prevents unauthorized devices from connecting to the network and improves physical security. Next, we will do demo on SSH verification. We open switch S1 CLI. Command show IP SSH. So SSH has been configured to provide secure remote administration. Unlike Telnet, SSH encrypts management traffic and protects administrator credentials. Next, we will do the backup PC. This is the improvement from version 1. So we open backup PC, show IP configuration. IP address 199.40.40.50, subnet mask 255.255.255.192, default gateway 199.40.40.1. So this is the backup PC added in version 2. The backup PC provides redundancy and support business continuity. It uses a unique IP address within the staff network to avoid address conflict. We open command prompt command FTP 199.40.40.60. So the backup PC successfully connects to the file server. This confirms that the backup workstation is fully operational and can continue business operation if a primary workstation becomes unavailable. In conclusion, we successfully designed and implemented a secure SOHO network for ABC Sdn Bhd. The network used VLAN, segmentation, access control, port security, SSH, and FTP services to improve security and network performance. All connectivity and security tests were successfully verified.
So for part B, we have to design a multi-building campus network. So for the objective is we have to design a secure campus network connecting main building, building 1, building 2, and also the remote branch, and support approximately 330 users with centralized service through a server farm, which is web, email, DNS, DHCP. Implement layer 2 and layer 3 switching with at least 2 routers of efficient communication. Provide secure wireless access in building lobby for authorized user. Enhance security using JCP snooping, dynamic ARP inspection, device hardening, and ACLs. And last one is develop VLSM IP addressing scheme and implement DMZ architecture for web server protection. Okay, so for the IP address range, for main building, the number of hosts needed is 160, and the number of hosts supported is 254, and the address range is from 199.40.40.1 until 199.40.40.254, and the subnet mask is 255.255.255.0/34. The subnet address is 199.40.40.0, and the default gateway is 199.40.40.1. Broadcast ID is 199.40.40.255, and the second one is the remote branch. The number of hosts needed is 100, and the number of hosts supported is 126. The address range is from 199.40.41.1 until 199.40.41.126, and the subnet mask is 255.255.255.12x/35. The subnet address is 199.40.41.0. The default gateway is 199.40.41.1. The broadcast ID is the 199.40.41.127, and the third one is the building 2. The number of hosts needed is 50, and the number of hosts supported is 62. The address range is from 199.40.41.129 until 199.40.41.190. The subnet mask is 255.255.255.192/26, and the subnet mask is 199.40.40.128. The default gateway is 199.40.41.129. The broadcast ID is 199.40.41.191, and the last one is building 1. The number of hosts needed is 20, and the number of hosts supported is 30. The address range is from 199.40.41.193 until 199.40.41.222, and the subnet mask is 255.255.255.224/27. The subnet mask is 199.40.41.192. The default gateway is 199.40.41.193, and the last one, broadcast ID is 199.40.41.223. Okay, so this is the IP address range for our server. So first is web server. The IPv4 address is 199.40.41.226, and the next one is subnet mask 255.255.255.240, and the default gateway is 199.40.41.225. DNS address is 199.40.41.228, and the next one is email server. The IPv4 address is 199.40.41.227. Subnet mask is 255.255.255.240. The default gateway is 199.40.41.225. The DNS address is 199.40.41.228. The third one is DNS server. The IPv4 address is 199.40.41.228. Subnet mask is 255.255.255.240. Default gateway is 199.40.41.225. The DNS address is 199.40.41.228, and the last one is DHCP server. The IPv4 address is 199.40.41.229. The subnet mask is 255.255.255.240. The default gateway is 199.40.41.225, and the last one is DNS address is 199.40.41.228.
Now, I will demo the part B. Firstly, we're testing about the device can getting IP address from DHCP in different building. So firstly, we test the main building and can successfully receive the for valid IP address or not. So as you can see, it successfully received a valid IP address. Next is our building 1. It's also same, it is successfully getting a valid IP address. For the building 2, it's also same, it is successfully getting a valid IP address. So for lastly is our branch. It's also same, it is successfully getting a valid IP address. Next, we test about the pin and threshold. First test is the main buildings can connect to the remote branch across the city or not. So we use the threshold protocol to test it. Firstly, you can find the PC2 at the branch 1 at the building 1, and the destination is the branch. So it shows that it is reachable. So next, let us test 2 is test about the different buildings can communications with each other or not. So let we pick the building 1 PC2 and building 2 PC3. So this shows that the pin is successfully and means that the different buildings can communications with each other. So for the test 3, it's about the remote branch computers can connect to its own router or not. So for the remote branch, default gateway is 199.40.41.1. So this is successfully. So continue shows the port security enabled on all the access interface. So for the main building L2 switch, it have the. So when I show port security, so it shows it have the this shows that it has a port securities from fast Ethernet 0 to 1 to 19. For the building 1 switch, it's also same. We also got it also have the port securities from fast Ethernet 0/1 to 19. For building 2, switch is also same. It also have the port securities from fast Ethernet 1 to 19. So here is the branch switch. It also have the port securities from fast Ethernet 1 to 19 and 21 to 24. Lastly, for the server switch, it also have the port securities from fast Ethernet 1 to 4. Next, we talk about the DHCP snowing verification. So DHCP snowing on main building is enabled. And the target protect VLANs is 10, 20, and 40. It ensures all the access ports within these user networks are actively monitored. Furthermore, we disable options 82 so that the backup lines can work properly without any issues. Finally, the upping interface Gigabyte Ethernet once is successfully configured as the true ports show yes. Why these ports aren't true is because the real DHCP servers is on our main uppings. If the hacker connects the fake server in the building 1, our switch log it immediately. It keeps our network 100% safe. For the building 1 is also same. The DHCP snooping is enabled and the options 82 is not allowed. It's disabled and the target protects VLANs is 10 and 20. For the building 2 is also same. So the DHCP snooping is enabled and the option 82 is disabled and the protect target VLANs is 10 and 20. So for the branch is also the same. DHCP snooping is enabled. Next, let us test about the access list. I will try to ping the server IP, which is using the laptop and at the main building. I will try to ping the server IP 199.40.41.226. This is the web server IP address. So as you can see, it's uneligible. It means that the main router successfully blocked the ping packet. Thus, the server farm is safe. So now let's check about the ACL rule matchings. So this proves that the router correctly detect and drop the 4 ping request from the PC. But the PC also can access the web service using by the web browser. So let's use back the laptop. We type the IP server and it can go through to the Cisco packet tracer pages. This means that it allows safe application traffic like the HTTP to pass through the firewalls while ping remain routed. Now I will explain about our backup design. We implement 3 different backup strategies to implement any single ports or faults. So firstly, we use the LACP ether channels between the main L3 switch and the server switch. So if I delete the one of the main cable, the traffic switch is actually latency with the 0 down. So when I open the laptop and try to get the IP address using by the DHCP, it is successfully. So this means that the server is never go to offline. Next, we also use the now we also use the pending tree protocol, which is STP between the building and other buildings, except the remote branch. So when I cut off the main lines between the main L3 and the building 1 switch, the backup lines will automatically turn to green, but it needs some time. So as you can see, after the backup line is turned green, now I try to get the IP address using the DHCP successfully. Now I try to delete the lines between the main L3 switch and building 2 switch. So it needs sometimes to waiting the light from orange to green. So when it turns green, let us try the DHCP is function or not. So it also functions. So means that after the backup line turns green, for the PC at the building 2 still can get the IP address. So lastly is for the connections between the main router and the remote router. So let's check the main port. So the Giga 0/1/0 is the main. So let us delete it. So when we delete the main line, the PC inside the branch is also can get the IP by using the DHCP. So actually for the connections between the main routers and remote routers, we use the floating static router over single mode fibers. Why we did not use the ether channels here? It's because the 10 kilometers distance makes it impossible. Instead, the floating route acts as the smart active standby backup. So if the main fiber line is disconnected, the routing stable instantly shifts the traffic to the backup lines. It ensures the remote branch stay connected. So that's all for us. Thank you.